sometimes it's helpful to work with only primitive streams. And what do I mean by that? Well, we've been working with streams of like type integer and big integer, not dot big integer, but everything's had to go through this wrapper class, right? But there's actually something called an int stream. So an int stream is a stream of primitive integer values. They are not what we call boxed into the integer wrapper class. Okay? So let's say, for example, that we want to generate, just as an example, infinitely many random integers between 1 and 10. Okay? So the first question is, how do we generate a random number between 1 and 10? Well, let's write an actual method for that. So gen between 1 and 10. Okay? So we can use this method called math.random. And we haven't really talked about this, but the way this method works is it returns a random double number between 0 and 1 exclusive. So inclusive on 0 and exclusive on the upper bound. So this can return 0.9999, repeating, but it will never return 1, and that's very important to realize. Okay? So the thing is, we want to return a number between 1 and 10, right? So that's sort of our goal here. So how are we going to go from this to this? Well, it's actually very simple. If we multiply both of these intervals by 10, what do we get? Well, we get something that is 0 and 10 exclusive, right? If we just multiply both bounds by 10, then we get this thing. And hopefully that's pretty easy to visualize. Okay? What if we add 1 to both of these? Then we get 1 and 11 exclusive. Okay? So now we have a method, we have a way of generating random double numbers between 1.0 inclusive and 11 exclusive. So this means we'll get something as a maximum like 10.999, repeating, but never 11. Okay? So now that we have that, how do we get this to be in between 1 and 10? Well, all we have to do is just truncate the decimal, right? Because if we have 10.99 repeating as our upper bound, then if we cast it to an integer, that's going to be 10. And 1.0 casted to an integer is also just 1. So all we have to do is just cast it to an integer. Okay? So I went very fast with that because this type of thing is not very complicated. And most Java, I'm pretty sure in learning Java, I go over this in chapter 1. So if you don't remember this example, then please go back and revisit one of the sections in chapter 1. Okay? So let's go to IntelliJ and write this. So this returns a number between 0 and 1 with 1 exclusive. So we'll multiply it by 10, and then we will add 1 onto that, and then we'll cast it to an integer. Okay? So this generates a random number between 1 and 10. And we'll just make it private because there's no reason to expose this to anyone outside of this class. Okay? So what we're going to do is we're going to say that this method the lambda expression doesn't return anything, and it just calls generate between 1 and 10. Okay? So now we could just replace this with the method reference because it doesn't receive anything, but we'll just leave it like this for the sake of making it simple. Okay? So now this is a stream of infinitely many random numbers between 1 and 10. And if we want to do things with this, which we can say, let's say we want to get 15 random numbers between 1 and 10, and then let's say we want to convert this to a list. But there's an issue. We can't just convert this directly to a list, because the problem is that lists use these reference types. You cannot just pass int to here, so we can't create a list of ints. what we can do is create a list of integers. Now, the way to convert, so here's the problem. The problem is that this is a stream of primitives. We want a stream of boxed integers. And there's a very easy way to get around this. So let's actually declare this in a variable just for the sake of really making it clear what's going on. So we're going to say is.limit. So we're going to get 15 of these. And then we're going to convert them to a boxed array, or a boxed stream, sorry. Where we go from this primitive int stream to a stream of integers. And now we're going to convert that into a list. Okay? So, what is going on? IntelliJ is weird sometimes. Anyway, let's now print out that list. Let's see what it looks like. Okay, so there we go. So we got 1, 4, 3, 6, 3, 3, 2, 4, 3, 10, 9, 10, 1, 4, 2. Okay? But there's some cool things that we can do on the stream itself. Okay? So let's say that we want to generate, let's say 6 numbers. Okay? So again, this is just another int stream. Okay? Because .limit is an intermediate operation. And in fact, let's do it right here, just so it's we don't need that separate variable for it. What we can do is there are some cool methods that we can call on the int stream itself. So for example, we can say, what is the max number in this stream? Okay, so let's run this and see what we get. We get optional int 7. So what happened here is we generated a stream of 6 numbers, a stream of 6 primitive integers, and then we called .max on it. So we want to get the max number, the max integer from this int stream. So just to visualize this, well actually we can't, never mind, so we're not going to visualize it. But the main thing I want to discuss is what this optional int means. So the first thing I want to ask is, or rather, like before we talk about what optional is, I want to explain what would, or rather, I want you to think about what would happen if we passed in 0 here. What if we have no stream, or what if we have a stream of nothing, right? So the question is, how do we compute the maximum of an empty stream, right? That question doesn't really make sense because, I mean, it's like, what is the maximum of an empty list of numbers? Well, there is no maximum. So what do you return? Do you return 0? Well, that doesn't really make sense because what happens if you have a stream where the maximum, or a list or whatever, where the maximum number is a 0, right? So that doesn't make sense. Negative numbers don't make sense because those can be the maximum of streams or lists or arrays where there's only negatives. So what do? Well, there's a solution to this, which is called optional. Okay, so optional is a very, very powerful concept. It allows us to represent the notion of something or nothing. Okay, so for example, if we have a stream of primitive integers and we want to compute the maximum, then we can do that, right? We can get the maximum very safely and we're fine. But what do we do if we have a stream that's empty? Then we return nothing. Okay? So in this first case we return something. In this case we return nothing. The optional class is a wrapper around data. Okay? So if we return an optional of an integer, then that means that we can return 2 things. We can return an integer or we can return nothing at all. So optional.empty represents the absence of a value. Optional.of represents the existence of something. Okay? Now, the thing is, this is optional integer. What we saw in that window was something called optional int. So Java has a few classes that represent optional primitives. Okay, so notice that this optional can represent any type at all, any reference type. But if we're just using primitives, then we don't need to use this generic optional. We're just going to use an optional int. So that represents the existence of a primitive integer or nothing at all. Okay? And as you can see here, if we limit our stream size to 0, then there can't possibly be a maximum, right? The same thing if we say the minimum. We can't have a minimum of nothing, right? But what about the sum? Would that be an optional? No, because you can take the sum of no numbers. That's just 0, okay? What about, let's say, the average? Does this make sense to be optional? Yes, it does. And in this case, it's an optional double, because remember that if you take the average of numbers, then that result can be a decimal. So we have an optional double type for that very reason. Okay? And in fact, there's double stream as well. So, we can do double stream dot generate, and let's say we want to create infinitely many random numbers between 0 and 1 exclusive. Okay? So now, this double stream represents the idea of there being infinitely many random numbers, okay, between 0 and 1. So if you want to, let's say we want to compute the, let's say we want to generate 5,000 of them and then compute the average of all of them. So if you think about it, the average of all of these numbers should very quickly converge to 0.5, because you have, if you pick some numbers on the low end, pick some numbers on the upper end of 0 and 1, if you average them all out, it should be 0.5. But if we just choose 5 numbers, it's going to be somewhere probably not very close to 0.5. But the closer that we get to that number, or the more numbers that we generate, the closer that we're going to approach to our true answer, to the true average of this sample. Okay, so that's just a statistics fact for you. But yeah, so dot average, dot min, dot max, dot sum, those are all very cool methods that you can use. There's a few others here that we'll probably talk about eventually, but yeah, so just look through these and see what you can find that's kind of cool.